Hello everyone. Welcome back to this video here where we're going to talk about calculator functions. The AP exam is calculator active for both the multiple choice and the free response section. So we might as well get used to it and learn how this thing can be really helpful for you. So in this video, my hope is to cover as many of the calculator functions as I can while explaining them, at least in some detail, for what applications you may see. So let's start right at the beginning. Unit 1, there's two big ones that you're going to use. It's under the distributions menu. So second vars brings me to the distributions menu. And the two biggest ones that I'm going to use here are normal CDF and inverse normal. Normal CDF is for any kind of z-score question where you're looking for a percentile. So in normal CDF, you will give it an upper and a lower limit, as well as the mean and standard deviation, and you will get back a percentage or a percentile. Inverse normal does the opposite, where you will give your calculator a percentile, and it will give you back a number. What's really important about these calculator functions is that you cannot write TI speak on the exam and expect to get full credit. They are incredibly picky about how you define what you write. So when in doubt with either of these, use the z-score formula to show your work, and then use normal CDF or inverse normal in order to get the solution. I cannot stress that enough, that writing normal CDF 20, 30, 7, 15 does not get you credit. So be very careful. These are tools to help you either get an answer or check an answer. They are not the end-all be-all of everything. Now, that being said, on the multiple choice section where work doesn't matter, immediately jump to these. There is no need to calculate a z-score unless the question asks specifically for the z-score, in which case, obviously, you would do that. So those are the two big ones from Unit 1. Unit 2 with linear regression, there isn't much on here that you will use. Unit 3 for sampling and experimental design, not a whole lot on here that you will use. Unit 4 for probability. We're in the same menu now, but they're all at the bottom. And the two, or I should say the four most important ones are right here. At the bottom here, your geometric PDF and geometric CDF. And then right here, your binomial CDF and your binomial PDF. One thing for both of these, PDF is a point estimate, or a point density function. So meaning X is equal to an exact number. So if you see exactly 2 successes, that's a binomial PDF. If you see that the first success is on the 5th launch of the rocket, that's a geometric PDF. The CDF functions, whether you're binomial or geometric, very importantly, are less than or equal to. I'm going to say that again. They are less than or equal to. And so you have to be very, very careful in how you use them. For example, in a binomial CDF scenario, if it asks for the probability of more than 3 successes, more than 3, that is 1 minus the CDF of 3. If it asks for 3 or more, it is 1 minus the CDF of 2. Because of the less than or equal to, I don't want to get rid of 3 successes. Worst case scenario is you can add all of the PDFs up. However, you may get a question where someone is taking 100 free throws and they want to know what's the probability that they make 60 or more. There's no way you're going to add together 41 binomial PDFs. So understanding how to use CDF in both cases is very, very important, because the input for these looks exactly the same. It's going to ask you for a number of trials. It's going to ask you for a probability of success, and then it's going to ask you for what is your x value, but your calculator doesn't specify whether it's a less than or equal to or a less than. Now, if you're lucky enough to have an Inspire is very easy because it has an upper bound and a lower bound. But if you're someone with a TI-84, this is the way that we have to use things, and so you have to be very, very careful in how you do this. This is not a reason why I would want anyone to lose points. Now, the other thing you can do on your calculator, as far as expected value goes, if you need to calculate expected value, I can go to the lists, and then in list 1, I can put my data points. In list 2, I can put the probabilities. And then to get my expected value, I can go to list 3. I can press enter, and I can type second 1 times second 2 to do list 1 times list 2, and press enter. And so now I have all of the contributions. In order to get the expected value, it is a very simple thing. I'm going to quit back to the home screen. If I press second stat, it brings me to the list menu. And if I go over to math, I can now sum list 3. Boom. There is my expected value. Granted, expected value is not that hard of a thing for you to do, just on your calculator out on the screen. So that's not a huge deal. But one way, if you have a larger table, I would say like, 6 or 7 things, that might be one way that's a little bit easier to do it. Now, the biggest thing with your calculator and where it's helpful is with all of this inference stuff, whether that's proportion intervals, mean intervals, or a hypothesis test of some kind, including chi-square. So all of those live in the stat menu, and then over to tests. Now, the one thing to be very careful of here is that a z-test is not for a mean. A z-test is for a mean. If you need a test for a proportion, that is the one proportion z-test. A z-test here itself, if I click on this, is going to ask me for a mean and a population standard deviation. So be very careful when you're in this menu and make sure that you are selecting the necessary things that you need. Same thing with a z-interval. A z-interval is for a mean. If you want the one proportion z-interval, that is down here at the bottom. If you have a TI-84, you'll notice you also have the chi-square goodness of fit, and then this chi-square test here is for homogeneity or independence, and you'll have to use the matrix menu. The last one you may use on here potentially is this linear regression t-test and linear regression t-interval. And so if you notice here, this would be if you actually had some data in list 1 and list 2, which I do right now, so we might as well do it. And there we go. I guess there's not a whole lot of correlation between the random example I made up with your expected value examples. But the biggest thing here, on the multiple choice section, no need to show work. Use your calculator as much as you possibly can. In the digital exam, there is no built-in calculator. And so your TI-83, 84, Inspire, whatever you have, is all you got. The other important thing, if you're someone who has a TI-83 and not a TI-84, this goodness of fit is not there. And you cannot do it other than trying to do it all in the lists in your calculator, and it becomes a mess. So I highly recommend, if it is possible for you, before the exam, find someone that you can borrow a TI-84 from. If you have a teacher, you can borrow one from. If you're going to college for any sort of STEM major, I may recommend purchasing a newer calculator, just for college anyway. But the TI-83s do not have goodness of fit on them. And then if a goodness of fit question shows up, you're going to be in a tough spot because you either have to do it all by hand, or you'll have to somehow try and work out a way in the lists in your calculator to do it. And I promise you, I've shown people, it is not fun. So that was a basic overview of your calculator functions. I hope that was helpful, and I'll see you guys in the next one. Bye.